So, hello everyone, back in track number 2 to probably today's highlight. Since the chatbot disaster of Microsoft, who turned immediately racist and with all the swear words, we are more and more aware of all this problematic about explainability, stability, overfitting, and fairness of the neural networks. I'm really glad that we have 2 experts on this field on stage today, which is Luca Baldassarre and Annapuma Datta. Please welcome on stage. Luca is the lead data scientist for Swiss Re's Advanced Analytical Center of Expertise since more than 3 years now. And Annapuma Datta is co-founder, president, and chief scientist of Truera. He is also professor of electrical and computer engineering and computer science at Carnegie Mellon University. Warm welcome. Stage is yours.
Thank you, everyone. It's a pleasure to be here and share the stage with Luca. We have been having some disagreements about things. We agree on most things, but not on some, and hopefully you'll see us fight a little bit here. I would put my money on him. So I want to kind of broaden the conversation a little bit. Although we often talk about explainability and fairness, in our mind, the broader problem here is about quality of AI models and systems and data in general. And you see the implications of that in practice in a very significant way. There are implications for performance. Some of you might be familiar with Zillow. It's a US-based marketplace that's used to buy and sell houses. And one of the things that Zillow did recently was that they were using machine learning models to estimate the prices of homes. And based on that, they purchased a whole bunch of homes. But then the housing market cooled. The machine learning models did not get adapted to the new reality, and they ended up losing $500 million and laid off a whole bunch of people as a consequence of that. So the implication of models that don't perform well, that don't get readjusted because the world has changed or the data distribution has changed, can be really, really real. Transparency and fairness, which is the focus of this session, is an important part of quality. We have seen lots of different examples. This one, the Apple Card example, Steve Wozniak, one of the co-founders of Apple, went on Twitter to complain how when he applied for the Apple Card, as his wife did as well, he got a significantly higher credit limit than his wife. And the concern was that the machine learning model under the hood was discriminating against women. The New York federal regulator investigated. The final conclusion was not that the machine learning model was discriminatory. In fact, there were differences between the applications based on net worth and income and so forth, because of which there were justifiable reasons for the difference in credit limit. But what it did bring to the fore is the lack of transparency in the existing system in the way it was deployed, and also the connection between fairness and explainability. That it's not enough just to look at top-level fairness metrics, but also to understand why one group might be getting less favorable outcomes than another, and get deeper into this question of, is that difference justifiable? And that brings up questions of root cause analysis, causality, and so forth, which we will talk about, both of us, as we go deeper into this conversation. The third thing, which is around quality over time. So you assess your models, you move them into production, but you have to assess quality, fairness, performance, and so on an ongoing basis, because these are not static invariants. They can change over time as the world changes, and we saw that a lot with the pandemic. Now, historically, the focus of evaluation and validation in machine learning has been on the accuracy of models, and there's a host of metrics for that. But accuracy is just the tip of the iceberg. There are a whole host of other considerations, a checklist, if you will, of requirements that you want to keep track of as you're assessing your machine learning models during development and in production. Just yesterday, I was moderating a panel, and we had in the audience, among the panelists, DJ Patil, who was the former US chief data scientist. And he was talking about the importance of having checklists, essentially a set of properties that you want to consistently test of your models related to model performance, societal factors like fairness and transparency, operational factors such as explainability, as well as data quality. Data is often the foundation from which many of these other elements emerge. And in this conversation, explainability and fairness are obviously extremely key elements. As we start thinking about the journey of taking ideas from the research and academic world into practice, what we have seen over time is an evolution from standards and governance, which often start out as high-level policy documents. You're seeing that in Europe now with the EU AI Act, which is in a draft stage. Other parts of the world, there's more activity there. In Singapore, for example, there is more clearer guidelines and standards. In the US, there are regulations that are much more specific, as are documents such as the SR 11.7 standard for model risk management, fair lending laws, and so forth. So once you go from the higher level policies to more operational standards, the next thing that's important is to have tools that support the checking of models, these checklists, and operationalizing them across the model lifecycle. This is an area on which there's been a lot of work. Truera, among other companies, provide these kinds of tools, coupled with training and education. What we are also seeing as data scientists, and we have many of you here in the room, a lot of this is the state of the art in the field, starting to move into practice, and there are gaps in education and training. And finally, in an organizational context, embedding it into operational processes. So what I'll show you quickly, instead of staying at an abstract level, is a quick demo in a video form of a fairness workflow, which will bring out, much like we saw in the UBS presentation earlier today, some of the top-level metrics for fairness, but also what some of the open questions in the end of that session was, how do you get to understanding the root causes of why a model might be treating two groups differently? And then we'll talk a little bit more after this demo.
Hello. In this fairness workflow demo, we do 6 things. 1. Define a protected group or group of interest. 2. Set a fairness objective. 3. Assess relative disadvantage for the protected group. 4. Assess root causes of disadvantage. 5. Conduct targeted interventions. And 6. Analyze fairness versus accuracy trade-off for each intervention. Protected groups can be introduced by creating new segments using one or more of the model's input features or an excluded input variable, which is not used for training. In this US-focused example, we chose to treat black households as the protected group. Note that the percentage of black households in the training dataset, 14.7%, is comparable to the overall black population in the US. The next step is to set out our fairness objective. We do this in 2 steps. First, we select a suitable fairness metric from a rich set of metrics available in the system. Then we set an acceptable range for the value of that metric. In this example, the metric chosen is equality of opportunity ratio, with an acceptable range of plus or minus 30%. The next step is to assess whether black households are significantly disadvantaged compared to the rest of the population. The answer seems to be yes. The equal opportunity ratio is just 0.55, instead of the ideal 1 or even the acceptable 0.7. Additionally, the model is also more inaccurate for black households, with an AUC of 0.84 compared to 0.94 for the rest of the population. Measuring relative disadvantage is arguably the easy part. Identifying the root causes behind such disparity is more difficult. Zooming in, we look for 2 things: features that are proxies for race, and features that might be difficult to justify due to their black box nature. Turns out that there are examples of both in this instance. The geocode and postcode features contribute more than 1/3 of the disparity between black households and the rest, and may be seen as proxies for race in the US context. Two other calculated features, underbanked flag and economic stability indicator, contribute about 20% more to the disparity. These are black box features and difficult to justify. So here we are with a baseline model that is inaccurate, perhaps unfairly biased, and dependent on potential proxy or black box features. What can we do by way of mitigation? Two things. First, we could remove these proxy and black box features and retrain the model. Second, we could supplement the existing data with complementary alternate data such as tax information. We tried both, with striking results. The equality of opportunity metric goes up from 0.55 in the original model, in green, to 0.66 after the first intervention, in blue, and then 0.71 after the second, in orange. Black households are now much less disadvantaged.
So the key takeaways here is that after you do this measurement of bias, which we have seen a lot of other presentations on as well, you do the root cause analysis, and that informs the mitigation strategy. The other topic I'll touch on briefly, and then I'll hand it over to Luca, is that choosing a fairness metric in a principled manner is a non-trivial exercise. And we saw that as an open question at the end of the UBS presentation earlier today. I will, in the interest of time, I'll just give you a very quick overview of how to think about this space, or at least one way of thinking about this space. On the x-axis here, on the y-axis here, vertically, are how much confidence do you have in the representativeness and accuracy of the labels. On the bottom here is a use case where we are thinking that historically, let's say based on gender, there has been bias in school admissions. So we don't have a lot of confidence in the representativeness and trustworthiness of the training data. So in this setting, we are saying we want to move to a world where the rate of approval of, let's say, or admission of women and men are about the same. This is something US universities tend to do, at least a set of those universities. This is called demographic parity or disparate impact ratio. On the top, we are assuming, like in a fraud example, that the data sets are pretty rich and the labels are accurate. In that setting, there are other kinds of fairness metrics related to equalizing certain kinds of error rates across groups that are more appropriate. And then there's more factoring based on whether you're causing harm or you're denying benefits to people. So in the interest of time, we'll return to this in the Q&A session, and I'll hand it over to Luca. Thank you very much.
Thank you, Anupam. 1, 2, 3. Good. Thanks, everybody. So why do we want to do an advanced analytics governance in big companies? Some of the motivation Anupam brought at the beginning, there's big financial losses, there's reputational damages, but more and more there's both external and internal pressures on achieving model transparency, having clear accountabilities, but also extracting more value from your data and models. And also having a faster time to market, faster development, faster reusability of existing models. So this is some of the things we're doing at Swiss Re to enhance these aspects, starting developing some standards and policies, providing guidelines on model development, but even before that, model scoping. Where should we invest our scarce data science resources to achieve the maximum business impact? And also finalize and systematize independent reviews of models that might not be reviewed by risk management or other functions. So these are models that are maybe deployed to improve business processes, increase efficiencies, not necessarily actuarial models that normally go through risk management reviews. This is exactly some of the one of the things we've been doing in the company for a couple of years now. It's called our kind of peer review framework. Initially, we only had the model review towards the end, but we realized that that is quite a thorough review, but it kind of comes too late. If you find that there are gaps in how the model was built, the gaps in performance, you kind of have kind of too little time, or you kind of wasted your time investment to correct those gaps. So we moved reviews early on in the process to ensure that there is a good, the team kind of follows a good direction, that there's a knowledge sharing between the experts in this peer review. And then we also introduced the code review more and more to ensure that the code is fit for purpose, robust, but also modular enough so that it can be easily reused. Not that the code is sitting in somebody's laptop and cannot be leveraged again. So I think some of the best practices have been discussed at this conference with many of you, really to systematize them across the company. And more aspects are related to explainability, fairness, and ethics. In order to enhance our expertise, our knowledge about these topics, we collaborated with the Monetary Authority of Singapore, who in 2018 kind of defined or redefined for the financial industries the FAIT principles: fairness, ethics, accountability, and transparency. Last year, we contributed to the Fairness Methodology Assessment white paper, which you can find following the QR code there. This year, we're working on transparency, on a predictive underwriting use case. And this really helps us to understand how to set up internal processes and guidelines to cover these aspects more systematically. And to reinforce the message that the fairness assessment, like transparency assessments, need to be done not just at the model validation step, but throughout the model lifecycle, from initially defining some clear standards on which notions of fairness apply in which context, to defining the groups of interest that may be due to regulatory reasons or to societal concerns, to assessing the bias that may be present in the data even before developing a model. So on the use case, the predictive underwriting, normally, for example, if you think about the traditional life underwriting process, you submit your application with a lot of questions, maybe rather lengthy. There is an underwriter that looks at these questions. Maybe there are some rules that they follow. They may ask for some more medical information, and then they make a decision whether to underwrite at the standard rate, underwrite with a loading, or decline the application. What we want to do with predictive underwriting really is this whole process. Instead of asking tons of questions, if it's an existing customer for which we already have some data and we have the consent to utilize this data for example, for marketing purposes, we can leverage this data with the model that determines who of existing customers may be eligible for an additional cover, an additional product, and market this to the existing customers, bypassing all this process, so that the customers receive the kind of a guaranteed offer. If they accept, they automatically underwritten at the standard rate. However, this process, since it's providing kind of a discrimination between eligible and ineligible clients, this might lead to some discrimination. So that's where we, in the white paper, we describe how we built the model and how we assessed its fairness. Here, it's on the false negative rate. We compare the false negative rate across gender, male and female, and also across ethnicity. This is based on a Singapore context where gender can be used, and there are also ethnicity. Mainly, it's just binary. It's either Chinese or other ethnicities. And what we found out that if we build a model that optimizes accuracy, this is biased. There is kind of males are disadvantaged, and we want to mitigate that. In order to mitigate that, we do a post-processing intervention. Basically, we select different acceptance thresholds on the predicted probability separately for males and females. And we see here that we slightly decrease the balance accuracy, which is our performance metric, but we can achieve the fairness objective that we have. However, this poses other questions. What other trade-offs are we making that are not made explicit by this analysis? And why was there this disparity in the first place? Can we correct it more thoroughly instead of changing these thresholds and decreasing the balanced accuracy? And this is what I wanted to share with you. Really happy to have more questions and continue the discussions that I already had with some of you throughout this great day.
Luca, Anupam, thank you very much. So are there questions directly from the audience? Just raise your hand. We have always the best audience here. They have questions.
So thank you very much for this great presentation. I have a question with respect to this choice of the fairness criterion. I mean, you said you do a choice, and you said we take the appropriate fairness criterion. Do you have any systematics behind that, and from which does that come?
So in this case, if you look at the white paper, we recommend some of these fairness decision trees, depending on the use case, that follow the schema that Anupam presented. First of all, we're asking what type of fairness we want to achieve. Is it a representative fairness that you might want to have for kind of school admission, or is it a performance type of fairness? You want the model to perform equally across the groups. And in this case, since the point of predictive underwriting or underwriting generally is really to discriminate on risks, we want that the model discriminates equally well across the two groups. So we went to the performance type of fairness metrics. And then we look what type of use case this is. Is it providing benefits? So it's an assistive type of use case or model, or is the punitive, for example, is a kind of declining application. In this case, it's offering additional process. In case you're not offered, you can still go through traditional underwriting. So it's really providing a benefit. So, and in that case, then we see which is the population that may be discriminated. The one that would be eligible to get the benefit, or the one who is not eligible. In this case, to provide the benefit, it's among all those people that are eligible, we want to ensure that they get the that as few of them as possible are not offered the benefit. So that that's where we got to the false negative rate. We want to provide the benefit to as many eligible people as possible.
Thank you.
Yeah, maybe just to add one sentence here to what Luca said. I was trying to go back to the slide, but this only lets us go forward in time, or forward on the slides. So if you think of that framework that I showed in that slide briefly, there were, oh, there you go.
Yeah, you speak.
The magic touch. I'll just wait for you. So go back one slide more. Okay. So what Luca pointed out is that it's in that top left corner, the false negative rate. And the reason for that is we do have a reasonable amount of data that is trustworthy. That's the assumption for these decisions. This is not a loan, it's a credit underwriting. And then because we are focusing on the benefits, if someone is denied this underwriting, then they lose out on some benefits. So that makes it reasonable to focus on the false negative rate, which is capturing what percentage of people in, say, women are getting, if they are starting to get more false negatives than men, then more women are missing out on the benefits. Depending on the use case, you kind of fit in different parts of this taxonomy. Other questions? There are quite a few other hands up.
Thanks for the presentation. I'd have a more general question. So we've often had this discussion, in the literature on fairness, there's this two categories, group fairness and individual fairness, right? Group fairness you described, and individual fairness is something that people somehow ignore, which simply means treating similar individuals similarly. What's your view, both industrial and academic, on these two notions? Which one should we follow?
It's a good question. I think we should look at both. And I think in the white paper, we also talk about individual fairness. I need to double check, but I remember we did some experiments. The tricky thing there is to define what's similar. And what we've done, it's kind of given the input features, find similar individuals, but that depends on the metric that you use to define distance within your input space.
But I meant more conceptually. So
conceptually,
philosophically, what would be?
I think what we should do more systematically is to understand also what civil society wants, because here we in our closed rooms, we discuss the fairness metrics, but what really do the end clients really perceive as fair or not fair? And within Swiss 3, we have a behavioral economics unit that is really doing this type of research to understand what maybe they don't really care so much about many of these subtleties, and they want a more kind of broader kind of concept of fairness. But I think that's also a bit of a criticism we got on this work, that what do the clients really want?
So I was hoping you'll ask a question that I disagree with Luca on, but so far we have not had that luck. So on individual fairness, there has been some amount of technical work, but where it has gotten stuck is exactly what Luca said. At a high level, like you said, similar people should be treated similarly. But how do you operationalize that? What does it mean for two people to be similar for the purpose of a task? If you knew how to define that, then you've kind of solved the problem already.
You can define it on a use case basis, just like the Apple Card.
So that was the second part of my answer, which is if you look at two very specific individuals in a use case, then what you get out of, and this is part of what happened in the Apple Card and some of the explainability connection, which is you can look at two individuals and ask, why was A denied the loan relative to B who was approved? And that, if that decision, and in the case of Steve Wozniak and his wife, if you look at, this is where the connection is between individual fairness and explainability, then you can see in that particular case, it was because of differences in net worth and income. At that point, you can make a judgment on whether that is acceptable for that use case, and the answer to that in that case was yes, and therefore it was viewed as. But how do you do it systematically ahead of time to ensure that the model treats every pair of similar individuals similarly? That is the part that's hard to do, because you don't have like a priori understanding of exactly what makes one person suitable for the task or suitable for the loan and another person not.
Yeah.
But yeah, those are really the great question, Pablo.
And maybe to quickly add technically to that, if you're able to solve that problem to define the good similarity metric, basically you know the manifold on which your points lies, and then you can use that also as your decision, basically do a nearest neighbor classification on that manifold, and you solve the problem. That's why it's so hard.
Yeah, and then you would have solved the problem that philosophers have been struggling for thousands of years as well.
If you promise to walk fast afterwards, we have time for one last short question and a short answer, which is difficult in ethics.
Okay.
One last. Short one.
You need to run.
Hi. You talked about root cause analysis, and you also mentioned in another place of the talk causality. Looking at the product as you currently have set it up, which is, I think, UI, user interface based. How do you, consider, let's say, actually the causality aspect, looking at Bayesian networks and these kind of approaches that have been evolved? For example, also for regression problems, and most of these are classification problems.
Yeah.
Have you looked into this? Sorry, that's maybe.
So I'll give a short answer and then allow Luca to give a short answer, because where I leave off, he will take it. So the short answer is that when I say root cause, I mean within the model. Given this model, there's a disparity, and that disparity is caused by the geocode feature in the training data. So it's like a sensitivity analysis that draws, the methods are similar to causality as studied by Julia Pearl, for example, that surfaces within the model, take that as the structural causal model, if you will, the machine learning model itself, and it's surfacing which of all the 500 features that are going into the model is causing the disparity. Now, what it isn't answering is, if you look at discrimination in the real world, is there a causal effect between geocode and the outcome that you're getting? So that the justifiability at that point relies on true causal analysis, which is outside of the scope of this work, but it is something that Luca is thinking about, so he'll solve that part of the problem.
Eventually, not yet, but yeah, it's something we're looking, because really this justifiability part, once we get the model explanation, that's a driving feature for the model, not for the underlying data, is that is that a justifiable feature due to a causal link? And then we're looking whether we can discover those causal links or kind of quantify the real kind of causal effect of certain features on the outcome. But it's very preliminary work. It will take some time before all these things come together.
It's a very hard problem, but like one area in which we have seen this, I know you want me to shut up, so I'll say one sentence and then I'll shut up, which is, this is something that we have seen econometrics and computer scientists who work on causality work on. So to give you one concrete example from the real world outside of computer science, and there were a bunch of people who came up to me and asked me, how can I get into a top US school today? So one of the things that came out of the work of James Heckman, who's an economist at U Chicago, got a Nobel Prize for some of his work on causality, was SAT scores are very strong predictors of race and have very little causal effect showing that they're predictors of success in college. And that's an example of a true causal conclusion. And as a result of that, a number of universities have stopped using SAT scores to make decisions about admissions. And the hope, or Luca's hope, I'm more skeptical about it still, but I'm willing to be convinced, is that some of that kind of causal reasoning can be done to tease out proxies which are truly impacting outcomes and eliminate them. I would be happy for that work to be successful, but there are a lot of open questions. It's a hard problem.
So I can assure there was no...
Thank you.
I can assure there was no fairness policy about the clicker. We have a technical glitch. Sorry about that. I personally am really happy that there was no actual fight here on stage. So you get the golden bottle with your name on it. Thank you very much for coming.
Thanks a lot.
Thank you all for joining track 2.